Evaluate a difference quotient, f of a plus h minus f of a divided by h. That is something you should memorize. For the function, and the function is f of x equals x cubed. What we're going to be doing here is we're really refreshing our function notation. So here, f of a plus h minus f of a divided by h is going to equal, for f of x equals x cubed, a plus h, the quantity cubed, minus a cubed divided by h. Remember how function notation goes, right? If f of x is equal to x cubed, then f2 is equal to 2 cubed. F of a is equal to a cubed. And then f of, if I were to say f of box, it equals box cubed, right? If I were then to put in a plus h in place of box, then I would be cubing the quantity a plus h. And that's what we have here. And I'm going to say something here that based on a mistake that I often see. Some people will say that f of a plus h in this case is a cubed plus h cubed, and that's absolutely not true. What we're doing is we're cubing the base. The base is a binomial, and so I'm going to expand that as a binomial. And so I have a cubed plus 3a squared h plus 3ah squared plus h cubed. You may recall that from pre-calculus binomial theorem. All of that is the a plus h cubed, and then I'm going to subtract off a cubed. That's from the second term in the numerator, and then we're going to divide this by h. Now folks, whenever we're simplifying a difference quotient, especially when it's an a plus h variety, what we're going to end up with is the numerator will simplify to the point that I'm able to divide out h. That's going to become our goal. You'll see why down the road, but for now, we can see that the a cubes subtract out. I'm left with 3a squared h plus 3ah squared plus h cubed divided by h. And then what we see is that h is a factor in all of the terms in the numerator. Once I factor that out and then divide the h, we end up with 3a squared plus 3ah plus h squared. That's our final answer. You may be wondering why we need this. Just sit tight. This is the beginning of the course, and a lot of the things we're going to do are going to be based on stuff like this. And with that in mind, we're going to look at one more example here. Same instructions, evaluate the difference quotient, which is going to be f of a plus h minus f of a divided by h, for the function given, which is f of x is equal to x plus 3 over x plus 1. I'll go ahead and get this started. F of a plus h is going to be a plus h plus 3 divided by a plus h plus 1. Remember, I'm substituting a plus h wherever I see x in the function expression. Minus f of a, that's going to be a plus 3 over a plus 1 divided by h. Now we have here a complex fraction. I'd like for you now to pause the video and simplify the complex fraction as much as you can. I forgot to say, don't multiply out in the denominator. Leave it with parentheses. Okay, go. Okay, I've got a lot on the screen here, but what I've done is I've, in the first term, divided out the a plus h plus 1, and I'm left with a plus h plus 3 times a plus 1. For the second term, it's the a plus 1 that divides out, so I have minus a plus 3 times a plus h plus 1. And the denominator is just h times a plus h plus 1 times a plus 1. I'm going to leave that factored. Foiling, or actually distributing in the numerator, clearing the parentheses, gives me a bunch of terms, but I can see here that the a squared subtracts out, the ah subtracts out, the 3a subtracts out, a subtracts out, and finally the 3 subtracts out. What I'm left with is h minus 3h. So that gives me negative 2h divided by h times a plus h plus 1 times a plus 1. And as I said before, when we are simplifying a difference quotient, the denominator is going to divide out, or at least a term in or a factor in the denominator is going to divide out. I'm left with negative 2 over the quantity of a plus h plus 1 times a plus 1 as our final answer.